Welcome to Maths and Science by IITian channel. In this lecture, we will be talking about rotation of masses and the unbalanced truth. That's finding Ixx, Iyy, Izz. Till now we have seen one particular rigid body is rotating about an axis. There are different masses are kept at different places. Then it's a collection of the system. How the system responds and how the system rotates and the truth behind it for calculating the Ixx, Iyy and Izz of the system. If different masses m1, m2, m3, m4 they are kept on axis or somewhere in the space, and we wanted to find the rotation of masses, the behavior of the rotation of masses. For that we are required to find out the moment of inertia. That moment of inertia is based on the moment of inertia tensor. This is where the tensor comes into play. And what is moment of inertia tensor? Ixx, a matrix of Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izzy and Izz. Then in a certain position, certain types of masses with certain mass m, m1, m2, m3 are kept at certain places in the space. Then how that system operates? The main crux of the rigid body motion or rotational motion is about finding the moment of inertia. Once moment of inertia is known, then we can find out the angular frequency as we have seen in the previous lectures. We can find out any factor. Moment of inertia is the crux of the problem in rotational motion or rigid body motion. If there are different types of masses and a collection of masses are kept in a particular way, in a particular system, what will be the moment of inertia and moment of inertia tensor of that particular system? That's what we are going to discuss now. This is a very important topic because in different directions, due to masses being placed at different places, we are able to collectively find out the moment of inertia of the system. Let us dwell into the problem. This type of problems do come in NEET physics and JEE physics. Two masses are kept at a horizontal distance of so and so. What is the moment of inertia? Effective moment of inertia. This type of questions. This is the basic concept which I am going to explain, maybe in a little bit scientific way, so that you can apply the same principles in your questions when are asked in the examination, like NEET physics or JEE physics. Now, first, what is the question? I framed one question for all of you, a simple question. Find the moment of inertia for the system when four masses of mass m each are kept on the x and y axis in xy plane at a distance of a from origin, find moment of inertia. The question is, there is a sphere as it is, here it is the sphere from the center. There is a sphere. I have just shown you a diagram of a sphere with axis. It is not showing the exact question. Question is framed now. Now, this is the y-axis, this is the x-axis, this is positive x, this is minus x, this is positive y, this is minus y. Or else you can even call it as x only, x-axis, positive, negative, that is not right, it is understood. Y-axis and x-axis. 4 masses. First mass m. 4 masses m, m, m. 4 masses are kept in the xy plane at a distance of a. What is the coordinate of this? A, 0, 0. A z-axis is also there. It is a 3-dimensional system. Z-axis is also there. It is a 3-dimensional system. It is a sphere. And another point here, the coordinates are 0, minus a, 0. Here for this m, coordinates are minus a, 0, 0. For this, coordinates are, because this is the meaning of the question given. This is 0, a, 0. This is, let us say, m1. This is, let us say, m2. This is, let us say, m3, m4. Here it is given that m1 is equal to m2 is equal to m3 is equal to m4 is equal to m. That is also given in the problem. Now, let's go for the solution. Let's go for the solution. We have to find out Ixx, Iyy and Izz. What is Ixx? Ixx is equal to sigma mi yi square, because it is with respect to x-axis, zi square. This is what I have explained in my previous classes. Please refer to the earlier lectures. This is Ixx. That is equal to, what is sigma mi? M is m1, m2, m3, m4, everything is m only. Mass is everywhere same. M1, M2, M3, M4, that is given in the question itself. Now this will be sigma m yi square plus zi square. Do you agree? Now we are required to find out yi square plus zi square, how much it is. Now mass m is kept, but it is at different positions. At what positions? M1 is kept at, let us very carefully do it. M1 is kept at A 0 0. That implies x1 is equal to A, y1 is equal to 0, z1 is equal to 0. M2 is kept at 0 A 0. From the diagram what we have assumed, 0 A 0. x1 is equal to, x2 is equal to 0, y2 is equal to A, z2 is equal to 0. Please, resolving like this, this is the major important step here. M3 is kept at minus A 0 0, x3 is equal to minus A, y3 is equal to 0, z3 is equal to 0. Then M4 is kept at 0 minus A 0, 0 minus A 0. That implies x4 is equal to 0, y4 is equal to minus A, z4 is equal to 0. This understanding you should have. That implies for Ixx sigma m into yi square plus zi square is equal to m into sigma y1 square plus z1 square iz square zi square. I is equal to, let us write like this, I is equal to 1 to 4. That implies Ixx is equal to m into, when I is 1, I is equal to 1 means y1 square is 0, z1 square is 0, 0 square plus 0 square, plus when I is equal to 2, y2 is equal to A, z2 is equal to 0. That means A square plus 0 square, plus when I is equal to 3, y3 is 0, z3 is 0, 0 square plus 0 square, plus y4 is I is equal to 4, y4 is minus A whole square plus z4 is 0. That is equal to m into 0 plus A square plus 0 plus A square. Minus A whole square is plus A square. That is 2m A square. Please try to understand this procedure. Ixx is equal to 2m A square. Then similarly, what is Iyy? M into Iyy is sigma mi xi square plus zi square. Sigma mi xi square plus zi square. That implies Iyy is equal to mi is same, m1, m2, m3, m4, that is same, m into sigma xi square plus zi square. Because we are calculating about y axis, we have to take x distance and z distance. That is equal to m into x1 square plus z1 square plus x2 square plus z2 square plus x3 square plus z3 square. This is the value of Iyy. Now let us substitute. Iyy is equal to m into, what is x1? x1 is a square plus 0 square, a square plus 0 square plus x2 square plus z2 square, x2 is 0, z2 is 0, 0 square plus 0 square. Here we have to add x4 also, we should not stop here, plus x4 square plus z4 square. Now x2 square, z2 square is over, x3 square plus z3 square, x3 is minus a, z3 is 0, minus a whole square plus 0 square, x4 plus z4, x4 is 0, z4 is 0, plus 0 square plus 0 square, that is equal to 2ma square. Iyy is 2ma square. Now what is the value of Izz? Izz is equal to sigma mi into xi square plus yi square. That is equal to m into, what is x1 square plus y1 square? What is x1? x1 is a square, y1 is 0, a square plus 0 square plus x2 square plus y2 square, x2 is 0, y2 is a, 0 square plus a square plus x3 square plus y3 square, x3 is minus a, y3 is 0, x3 is minus a whole square plus y3 is 0 square plus x4 square plus y4 square, x4 is 0 square plus minus a whole square y4. This is coming to m into a square plus a square plus a square plus a square. That is equal to 4ma square. Now we have got Ixx value, Iyy value, Izz value. These are 2ma square, 2ma square and 4ma square. Now the net moment of inertia when the rotation of the masses is about an axis making equal angles. Let us find out. A addendum question, additional question to this. Find mi of system when system rotates about an axis making equal angles with all axes. In that case, angle is alpha, beta, gamma. Let us say solution. Angles is equal to alpha is equal to beta is equal to gamma, because equal angles it is making with the axis. axis of rotation is about the axis which is making an equal angle with the axis. Axis is XYZ. Rotational axis angles with X, Y and Z axis is equal to alpha, let us say, equal, let us say approximate, let us say it is alpha. Or we can even say alpha, you may get confused, let us rather say, we will call this as theta. This will be theta. Then, as per the vectors and directional cosines, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Do you agree to it? Because alpha, beta and gamma are same, they are making the same angle. They are making the same angle. Unit vector of the unit vector of rotation about which system is rotating one by root 3 into I plus j plus k. This is the unit vector. And the moment of inertia tensor is equal to, as we have calculated, Ixx is 2ma square, others are 0 because of the symmetry, and Iyy is 2ma square, others are 0 because of symmetry, Izz is 4ma square. This is I. Unit vector is equal to, directional unit vector is equal to 1 by root 3 into I plus j plus k, and moment of inertia tensor is equal to 2ma square 0 0 0 2ma square 0 0 0 4ma square. These two will result in I is equal to 1 by root 3 into 1 by root 3 into 2ma square plus 2ma square plus 4ma square, that is equal to 8 by 3 ma square. How this we have got it? I want to leave it as a homework. You please recollect I is equal to N transpose I N. This is what you should recollect. because this is how to, when you know the moment of inertia, when you know the unit vector in that particular direction, I have already explained you in my previous classes how to calculate it. What is the formula for calculating? I know the unit vector, I know the tensor. Once I know the tensor and unit vector, how we have to calculate? That's already given. If you have any doubts, you can put it in the this. For your brevity, I will write like this: 1 by root 3. From this, you please try to calculate on your own. 111 dot 2ma square 0 0 0 2ma square 0 0 0 4ma square into 1 by root 3. Here it is transpose, here it is straight. Transpose is a row matrix. This 1 by root 3 into 1 by root 3 will become 1 by 3, and this whole becomes the addition of this, and the answer is this. Hence, the moment of inertia is equal to 8ma square, Ixx is equal to 2ma square, 8 by 3ma square, Iyy is equal to 2ma square, Izzz is equal to 4ma square, and tensor is equal to 2ma square 0 0 0 2ma square 0 0 0 4ma square. Even the question is not asked about forming the tensor. We have formed it for our better understanding, so that we will not miss out on any step. Ultimately, it is 1 by 3 into sum of the moment of inertias Ixx, Iyy and Izzz. You can see Ixx is equal to Iyy, but Izzz is double than Ixx and Iyy. Why the reason? When parallel axis theorem, Izzz is equal to Ixx plus Iyy. Just relate each other. I am just only, it came to my mind to write like this: find out whether it is correct or not. If correct, derive it. If not, why the result is showing as above. You use your intuition and intellectual brain to brainstorm this type of questions. When this type of questions are asked in the examination, you will be able to understand that. With this, I want to conclude this lecture. Best of luck to everybody. Thank you for seeing my lecture. And if you feel there is a value addition to your knowledge, please share my videos, subscribe to my channel, Maths and Science by IITian. Thank you for listening to me. Thank you for viewing my lecture. Best of luck.